Hello friends, today we will discuss about Norton Theorem. Suppose this is a network. This network has two terminals. So this is a two-terminal network. It must be a linear network. It should be also a bilateral network, and this network may contain several number of passive element and active element. Passive element means resistor, capacitor and inductor, and active element means various energy source, that means current source and voltage source. It may be dependent energy source or independent energy source. So this network looks very complex, so it is very difficult to calculate the current, voltage or power in specific circuit element. That's why we should transfer it into a simple network by using Norton Theorem. So according to Norton Theorem, this network can be replaced by a current source. In parallel to a equivalent impedance Rn. This is the terminal A and B, where In equals to the equivalent current source. It can be written as short circuited current through given terminal. And what is the Rn? Rn is the equivalent impedance or resistance seen across this given terminal. Seen across the given terminal. By replacing all the voltage source with their internal impedance and all the current source are kept as open. This is the Rn and In. So what is the statement of Norton Theorem? Any two-terminal linear bilateral network containing several number of active or passive element can be replaced by an equivalent current source in parallel to an equivalent impedance or resistance, where the equivalent current source is the current, short circuited current through the given terminal, and the equivalent resistance is equals to the equivalent resistance seen across the given terminal by replacing all the independent voltage source with their internal resistance and independent current source with are kept as open. So this is the Norton's theorem. Now, what is the limitation of this Norton theorem? Here you see that this theorem only valid for linear network. So if the circuit contain nonlinear element, then you cannot apply Norton theorem. And this Norton theorem can be valid as AC source, DC source, and it can be applied in time domain as well as frequency domain. Now I will solve this problem. This problem contains one independent voltage source and this one dependent voltage source. Okay, so how to calculate the Norton equivalent Norton current source and the Norton equivalent resistance in this circuit? So this is a voltage source, this is dependent voltage source, and this is load resistance. So this circuit contain dependent and independent energy source. So how to calculate this problem? So number one, you have to calculate the ISC, that means IN equals to ISC, short circuited current to the given terminal. So this is the terminal, this is the terminal. So this terminal can be, you have to short circuit it. So this is the current, short circuited current. This is the short circuited current. You have to calculate this short circuited current because IN equals to ISC. So how to calculate? Suppose this is a mesh 1. So this current, suppose this current is I1. So this is mesh 1. And this mesh is 2. This is mesh 2. And this current is suppose I2. So if I apply the KVL, so from this branch we can write that I equals to I1 minus I2. So this is equation number 1. So this is the 2I and this is I. So I have taken I1 in this direction and I2 in this direction. So this small I can be written as I1 minus I2. This is the equation number 1. Now applying KVL at node at mesh 1. This is the direction. So this is plus minus minus plus. So I1 into 4 minus 2I. This is plus minus. So this is plus 3 into I1 minus I2 minus 10 equals to 0. So if I put this value I1 and I2 instead of I, so what will be the equation? This is 4I1 and this will be can be written as I1 minus I2. This is 3 multiplied by I1 minus I2 equals to 10. So this is 4I1, this is minus 2I1 and this is 3I1. So next step it will be 4, 2 and 3. So it will be 5I1. This is plus I2, this is minus I2. So it can be written as minus I2 equals to 10. This is equation number 2. This is equation number 2. Now if you apply the KVL at mesh 2, so applying KVL at mesh 2. What will be the equation? Suppose this is plus minus, so 6I2, and this, if you taken, this is plus minus, so the current, this is plus minus, so minus plus, so it can be written as minus. Okay, so current through this is I1 minus I2 equals to 0. So if you taken current, direction of current in this way, so this is plus minus minus plus, so the current through this direction is I1 minus I2. So in this way it can be written as 6 this is also a 3, so it is 3. Okay, so 3 into I1 minus I2, so it will be I6I2 minus 3I1 plus 3I2 equals to 0. So it will be 3, this is 9I2 equals to 3I1. So this is 3I2 equals to I1. So this is equation number 3. Okay, so if you solve these two equations 2 and 3, so from equation 2 and 3, we can write that 5 into I1 means 3I2, so this is 3I2 minus I2 equals to 10. So from this equation we can write that this is 15I2 minus I2 equals to 10, so it can be written as 14I2 equals to 10, or I2 equals to 10 by 14. So if you divided this function 10 by 14, so it will be 0.714 ampere suppose. So this is the I2, so I2 equals to ISC, so I2 equals to ISC, ISC means the IN, so IN equals to 0.714 ampere. This is the IN. Now you have to calculate the RN, that means equivalent impedance. So how to calculate equivalent impedance? This is the rule for calculation of IN. So how to calculate RN? RN can be calculated as VOC divided by ISC. So you have to calculate the open circuit voltage, that means Thevenin voltage divided by ISC. So from this circuit we have to calculate the open circuit voltage across this terminal and or VTH across this terminal. You cannot calculate the equivalent resistance seen across this terminal because this is a dependent energy source. If the circuit contains dependent energy source, then you cannot calculate the equivalent resistance by seeing across this terminal. So to calculate this RN, you have to calculate the open circuit voltage across the open circuit terminal. This is the open circuit. So if you want to calculate the open circuit voltage VOC, you have to calculate this I. If you are able to calculate this I, then this is the 3 ohms, this is the 4 ohms, this is 10, this is 2I. So if I take the current in this direction, then using KVL we can easily calculate this I. So if we are able to calculate I, then I into 3, it will be the open circuit voltage across this terminal. So applying KVL at this mesh, we can write that 4I, this is plus minus, this is minus plus, so 4I minus 2I plus 3I minus 10 equals to 0. So it is 5I equals to 10. This is 5I equals to 10. So I equals to 10 by 5. So it is 2 ampere. It is 2 ampere. Then VOC, that means V Thevenin, it will be 3 multiplied by I. So 3 into 2, it will be 6 volt. So this is the 6 volt. So if this is 6 volt and ISC I have already calculated that ISC is equals to the 0.714 ampere, then RN is equals to the VOC divided by ISC, that means VOC equal to 6 and then it will be 7.14. So it will be 6 divided by 7.714, it will be 8.4 ohm. Okay, so this circuit can be transformed in this way. This is the energy source IN. So IN is equals to 0.714 ampere and this is the parallel resistance. This parallel resistance Rn equals to the 8.4 ohm. This is the equivalent Norton circuit from this circuit. Okay, so in the next class I will discuss the problem, the circuit containing independent energy source.